So good evening to all of you. Good evening to all of you. Yes. So शुरू करें? Should I start then? Okay. This video is for Benjin batch English, so I have to continue in English. So, yeah. So just say hi. Who are there? Just say hi. I know that JAM 2021 result is already out. Not result, the response sheet, and the solution will be coming as soon as possible. Like I have made the solution, so I'll be coming live tonight by solving you the AMC question, MS question, and NAT questions. Okay. Just I'll be coming live and I'll be solving all the questions in live classes. Fine. Yes, and this class is specially for Benjin batch English JAM 2022. So as this exam has finished, so we have to focus for the next year examination. Fine. We shouldn't waste any time. Okay, yeah, Selvam, Ashwin, Mamidi. When live? Okay, it would be live likely 8 to 8:30. 8 p.m. to 8:30 p.m. I'll be coming live for solving to solve the previous year questions of JAM 2021 in live classes tonight 8 to 8:30 p.m. Yes, today, not today, tonight. Okay. Yes, tonight. I think we are having some issue with the internet. I think. Just 1 second. Okay, now it's fine. So just tell me, should I start then? Tell me, should I start? This class is going to be little bit mathematical classes because from this section we are understanding quantum mechanics. So from this section most of the cases mathematical problem comes in the examination. Okay, so whatever we learn in this class will be more or less more mathematical, less chemical. Fine. So tell me, should I start then? Should I start this class? Because in the last class we talked about a lot of things regarding Schrodinger wave equation. In this class we will be solving some mathematical problems regarding Schrodinger wave equation. But before I do that, I will be recapitulating those things which you have already completed, and then we will be moving forward. Fine. Okay, great. So once again, good evening to all of you. So in this class we will be talking about some important functions that we have understood in the last class. So what about those important functions? Let me talk about those. In the last class, let me show you, I have told you that you will be getting a lot of solutions of psi. You will be getting a lot of solutions for this wave function psi, and the reason behind this is this psi is this Schrodinger wave equation is the second order differential equation, and because of that, whenever you are solving this second order differential equation, this psi value, like you will be getting a lot of psi values. And out of all those psi values, all those values will not be accepted, only certain values will be accepted. So which value will be accepted? Those values which will be like fulfilling or which will be satisfying certain conditions. Certain conditions means these conditions. So the values, the psi values which are satisfying these conditions, those will be accepted psi values, and other values will not be accepted psi values. Simple. I told you this thing. Now I am starting from this section, and I am telling you what I told yesterday, what I told in the last class, and what I am going to tell in this class. Fine. So first of all, this psi, from where you are getting this psi? By solving the Schrodinger wave equation for a particular system. That system can be your hydrogen atom, that system can be your any other one electronic system. For multi-electronic system it becomes little bit complicated, but yeah, for a system we can solve the Schrodinger wave equation. So after solving the Schrodinger wave equation, we will be getting a lot of psi values. Okay, and we will be getting a lot of psi values. So I am taking, suppose that value is psi 1 or psi 2 or psi 3 or psi 4. I can get any values or dot. But out of this psi 1, psi 2, psi 3, psi 4, suppose I am thinking, I am just considering, I don't know what is psi 1, what is psi 2, what is psi 3, what is psi 4. I don't know anything. So out of all these values, I am considering that this psi 1 is accepted, psi 2 is accepted, but all other values are not accepted. The reason is why? Because these psi 1 and psi 2, they are satisfying all the conditions. They are satisfying all the conditions. Condition 1, condition 2, 3, 4, 5, 6, 7, 8. Like whatever conditions are there. Because of that, this psi1 and this psi2, these are accepted wave functions. Okay. Now if I tell you, okay, psi1 and psi2, these are accepted. Now why they are accepted? Because they are satisfying all these conditions. Now I am taking only two conditions from these, all of these possible conditions, and I am explaining more. I am explaining all those two possible conditions. Let me tell you which conditions I am talking about. So you know, if a psi value needs to be satisfied, needs to be accepted, that psi should be continuous, that psi value should be finite, that psi value should be single valued for a particular point, that psi value should, that differential of that psi value should also be continuous, then psi or psi square should vanish at infinity. Then I told you, your psi should be normalized and your psi should be orthogonal. So I know that as those psi1 and psi2 that I had taken already, those are accepted. That means those are satisfying all these conditions. Now out of all these conditions, I am just taking normalization condition and orthogonality condition. Why? Because I want to make you understand what is normalization exactly and what is orthogonal exactly. Because it's very important to understand normalization as well as orthogonality. Fine. So as these two are accepted wave function, that means these two functions, they are normalized, or simply I am writing normalized, and as well as, and also they are orthogonal, right? They are normalized, they are orthogonal. Now question arises, what do you mean by normalized? What do you mean by orthogonal for these two different functions? Even if you are getting three different functions, then you can also apply this concept. If you can take 4 different functions which are accepted, you can apply same concept. So I am taking only 2 functions intentionally, that's all. There is no logic behind this, that why I am taking only 2 solutions. There is no logic. I am just taking, that's all. You can take 3, 4, whatever it is. But I am considering that these 2 functions, these 2 psi values, psi1 and psi2, these are accepted. Now if I discuss this thing, if I go and discuss this thing more accurately, what do you mean by normalization? What do you mean by the orthogonality? Then it will be further much more better. So what do you mean by normalization? What do you mean by that? Normalization means basically, suppose, as I already told you, you are getting psi1 and psi2. So for normalization, take psi1 or take psi2. Any one function, any one wave function, just take only one. In that case, in the last class I told you, normalization means what? In the specified space, that means that space can be 1D space, that space can be 2-dimensional space, that space can be 3-dimensional space. So whatever space I am talking about, that in that space, I am thinking it's all space. All space means I am thinking it's a 3-dimensional space. I am just thinking, okay. Normalization means at that space, your wave function means here I am taking, suppose, only psi1. So psi1 square, that means I am multiplying psi1 twice, that's all. Psi1 square and d tau, that value will be equals to 1. Great. Understood? And what do you mean by this d tau? D tau means, as I told you, I am taking these in all space. All space means 3-dimensional space. It is d tau equals to dx, dy, dz. Nothing to worry. We will be discussing this d tau later on as well. Okay, nothing to worry. So that's about d tau. It represents 3-dimensional space. That's all. And this is the condition for normalization. Great. Now, as we have applied the normalization factor for psi1, because it is accepted, so I can apply same thing for psi2 as well. Yes. So you can apply same equation, same concept, same normalization concept for psi2. So all space psi2 square d tau equals to 1. Now why it is looking like this, or what do you mean by this? So you can say this thing in 2 different ways. First of all, as your psi1 is normalized, therefore you can write this expression in this way, or you can say as this psi1 square d tau in this space equals to 1, that is why your psi1 wave function is normalized. Okay, psi1 wave function is normalized because the value that you are getting is equal to 1, or psi2 similarly psi2 wave function is normalized because it is 1. Or I can say in this way that as psi1 or psi2 they are accepted, that's why they will be normalized. Definitely, that's why normalized. And I consider that here psi1 is real and also psi2 is real. These are real functions. That means there is no imaginary term present in the psi1 or psi2. That means there is no I term present in the psi1 or psi2. But I don't know what is the value of psi1 exactly, whether it is real or imaginary, because I can get real value as well as imaginary value and both can be accepted. So I will be showing you in this class that how real value will be accepted or imaginary value will be accepted. So it can be real or it can be imaginary, but both will be accepted. So I will be showing you that one. But before I go there, just tell me one thing. I thought that it is real, that's why it is following this normalization constant. What happens if this psi1 and psi2 they are not real, they are imaginary? What could you do then? What would you do then? So whenever they were considering that they are not imaginary, they are not real, they are imaginary, so at the same space, how can you solve this problem? How can you write the normalization condition? So you will be writing in this way: psi1 and its complex conjugate multiplied by normal psi1, then d tau equals to 1. Similarly, psi2 all space psi2 star psi2 d tau equals to 1. So in this way you will be representing your expressions. So in the last class I already told you, so I am not elaborating this thing once again. So what do you mean by this psi1 star? Psi1 star means psi1 star is the complex conjugate of psi1. So why I am multiplying this complex conjugate? Simple reason, so that I get, whenever I am multiplying this psi1 star and psi1, I get a real value. And here as psi1 was real value already, so I can easily do only psi1 into psi1, that means psi1 square. Because it is real, psi1 is real, so psi1 square will also be real. But as psi1 was not real, psi1 was what? It was imaginary. So that is why I am multiplying this psi1 with its conjugate pair, conjugate system, conjugate wave function, so that it becomes, whenever I am multiplying this psi1 star and psi1, the overall term becomes a real term. So psi1 is imaginary, psi1 star is also imaginary, but whenever I am multiplying these two, it is a real function. Because imaginary means what? There is no real existence of that function. That's all about imaginary. So because of that we need to get the real function. That is the logic behind this. Similarly, if you consider psi2 and psi2 star, same thing you will be getting. So psi2 will be what? Psi2 is your imaginary function. It is your imaginary function. And because of that, psi2 star is also imaginary, but it is its complex conjugate. And whenever it is its complex conjugate, so what do you mean by that? That means whenever you are multiplying these two, overall term will be real. That's all. So this is the condition of normalization. So I hope you understood that as psi1 and psi2, these are accepted wave functions, that means they will be normalized. That means this value will be 1, this value will be 1, or this value will be 1, or this value will be 1. Value will be 1 because they are normalized. Great. Now another condition I told you I will be talking about, that's your orthogonality. So what do you mean by this term orthogonality? What do you mean? Orthogonality. It means now you are getting two different wave functions. Okay, two different wave functions. Understand this. So to represent this normalization, you don't need two different wave functions. You just need only one single wave function. But to represent orthogonality, you need two different wave functions. And here psi1 and psi2, these are two different wave functions. Got it? Now if you look at this psi1 and psi2 properly, what will be the condition for orthogonality? So these psi1 and psi2, they, whenever as they are accepted wave functions, they will be orthogonal to each other. Again I am repeating, psi1 and psi2, both are accepted wave functions, that means those are fulfilling all the conditions, and as they are accepted they will be orthogonal to each other, or conversely I can say, as these two are orthogonal to each other, maybe they are accepted, but definitely I already considered they are accepted, these two are accepted, definitely they will be orthogonal to each other. That means to represent orthogonality I need to represent psi1 and psi2 both. How can I represent that? Simple, same thing, all space means whatever space I am specifying. So I will be coming into that as well whenever I will be giving you examples. Okay, all space. Then psi1, psi2 d tau, that value should be 0. Look at this, look at the difference. In case of normalization, psi1 square or psi1 psi1, psi2 square or psi2 psi2, every time I am taking only one wave function, but in case of orthogonality I am taking two different wave functions, and if these two different wave functions are accepted, then psi1 and psi2 they will be 0. So I am writing this expression by considering that both of these wave functions are what? Real wave functions. That's why I am not putting any kind of star. But if they are not real, so what condition they will satisfy then? You know it, you already understood this, simple. So take just if they are not real, just take one wave function's complex conjugate value like psi1 star and another one normal psi2, or opposite one, that will be 0, or simply all space psi2 star psi2 d tau equals to 0, opposite one just. Okay, I'm sorry, it is psi1. It is psi1. Psi2 star psi1. But whenever, remember one thing, these equations are correct whenever this function is they are not real function, they are imaginary function. Imaginary function, okay? These are real at that time, imaginary. Correct. But remember a very important point over here. Do not take psi2 star psi1 star. Do not take. You cannot take both of these complex conjugate term. No. Take only one complex conjugate term and another will be normal imaginary term. Then you will be multiplying these two and definitely you will be getting a real function. That's all. Okay. So this one is for real. These two are for imaginary functions. Another mistake you will be doing over here. So mistake, I am writing it as hashtag mistake. Hashtag mistake. Another mistake you have to avoid, that is about whenever you are writing psi1 and psi2 or like this one, whatever it is. Look at this, every time I am putting star, I mean complex conjugate term earlier or before, then the normal term. Complex conjugate, then normal. Complex conjugate, then normal. Complex conjugate, then normal. Do not put here, do not put psi2 and psi1 star. The logic is, I am not saying that it is wrong. I am not saying it is wrong. Actually, I will be saying it is wrong convention. It is wrong convention. So to get the right convention, to write through the right convention, you will be following, you need to follow this rule that first of all you need to read psi1 star, then you need to read psi2, like that. I mean the conjugate term first, then normal term. Conjugate term first, then normal term. And if you follow some books, maximum international and reputed books are following these rules, but Indian author or like local books, they don't follow this rule. And you will be knowing the reason is simple. Because whenever you are reading any local books, they don't care about these kinds of convention, because these are very perfect international conventions that physicists, chemists generally discovered, and they used. So please, whenever you are writing, do respect them and please write in this way. That's all. Okay. Next, let's move forward. You have understood this orthogonality. So now, suppose I am creating a situation, a odd situation. What kind of situation? Suppose I have a function psi. Suppose I have a function psi, it's a wave function. But I am telling that this wave function is satisfying all the conditions, except one conditions. It is satisfying all the conditions except one condition. What condition it is? So it is not satisfying the normalization conditions. It is not satisfying the normalization condition. So what would I do? What would I do then? So psi is a function. It is satisfying all other conditions. It is not satisfying only the normalization condition. That means psi is not an acceptable wave function. Acceptable wave function, definitely, because I told you it needs to satisfy all the conditions, then only it will become an acceptable wave function. So it is not an acceptable wave function because it is not normalized. That means suppose I am considering psi is real, I am considering that thing as well. It is not normalized means what? It means all space or the specified space, all space psi 1 square or psi square, definitely d tau will not equal to 1. So if it is not equal to 1, that means it is not normalized. So if it is not normalized, then your psi will be accepted or will not be accepted. Definitely will not be accepted. Now I am creating a situation that psi is not a normalized function. This is a very important part, okay? Psi is not a normalized wave function. But I want to make it normalized. Very important thing. I want to make it normalized. I want to make it normalized. So initially it is not normalized. Okay? But I want to make it normalized. How can I make it normalized? Question is this. Very simple. Very simple. Psi, it is not normalized. So to make this psi normalized, what I am doing, I am multiplying a constant with this psi. Okay, initially this was not normalized, so I am multiplying a constant a. Suppose any constant, whatever you can say, a, you can take anything. I am taking a. I am multiplying a constant. It is a constant, okay? Constant, and it was what? Non-normalized or unnormalized or not a normalized wave function. Not a normalized wave function. Great. Not a normalized wave function. So simply, if it is not a normalized wave function initially, I am multiplying a to normalize it. That means now if I consider the whole function, this whole function is normalized. Okay, this whole function is normalized. So initially it was not normalized. Here I am multiplying with a constant, and after multiplying it, the whole function is becoming normalized. Understood this? If you understood this thing, please write C in the comment box. Please do write C in the comment box. Please write C. It is very important thing. Initially it was not normalized. Now after multiplying with a, it is becoming normalized. Now you can ask me, okay, you are multiplying with a, so what is the value of a? What is the value of a? Value of a. Because I am taking a as a constant. What is the value of a? Yes, Ashwin, same question you are asking me. What is the value of a? How could I get the value? Now I told you already, if your function is normalized, then definitely your function will follow, will satisfy this normalization condition, definitely, if your function is normalized. Now logically, initially it was not normalized, but after multiplying by a, it is becoming normalized. That is, now after becoming normalized, it will follow the normalization condition. That means in all space, this a psi twice you have to take. Again a psi, d tau, I am taking d tau, that will be equals to 1, definitely. that will be equals to 1, definitely, because I am taking this function and I am considering that the whole function is real function. So you can ask me why, how can I know this is real or imaginary? I am thinking it is real. In future in this chapter I will be showing you that in which case which function is real or which are not real, or what is the real situation. Whenever real situations are coming, like what will happen, everything I will be showing you, nothing to worry. But I am thinking this overall function is real function, so I am not taking any complex conjugate term. Okay, so now look at this equation. In this equation, this psi is your wave function and a, these are constants. So can I write this expression in this way? All space, and I am taking this a square out of the system. It is your psi square d tau equals to 1. And now, if you look at this thing properly, if you look at this system properly, what will happen? From here I can write integration of all space psi square d tau equals to 1 by a square, or from here I can say integration of all space psi square d tau equals to a to the power minus 2, or from here I can say okay, now from here I can easily calculate the value of a. I can easily calculate the value of a simply. Yes or no? I can easily calculate the value of a. Look at this. So you can easily solve the integration, and once you can solve easily the integration, then just it is a to the power minus 2. Send the minus 2 over there, you will be getting your answer simply. Okay, or if I put the value, then it will be looking like this. It is odd, but it will be looking like this. All space psi square d tau minus 1 by 2. That's your a value. So in this way you can find the value of a. You can find the value of a. And do you know what is this a actually? This a is called normalization constant. Normalization constant. Okay, this a is called normalization constant. That means this a is a constant that is actually called NC, normalization constant. Now I am just giving you brief idea regarding this normalization constant. Now let me solve a real problem, then it would be better. So I am taking, there is a function psi x, and the value of the function is x square. It's a function, and it's not acceptable wave function, not an acceptable wave function. I am telling you, not an acceptable wave function. So what you will be doing to make this wave function as an acceptable wave function? You will be doing what? You will be multiplying with a. You will be multiplying with a. Now this function, suppose, is your acceptable wave function. Okay. Now can you calculate the value of a? So what I am doing, I am giving you certain informations that this wave function or this function is valid only along x-axis. That means only along one dimension, that's all. I am giving you the range. So whenever this function is present, this function has a limit. That limit is 0 to, suppose, 2. Limit is 0 to 2. This is the limit of the wave function and on the x-axis. This is the limit of the wave function on the x-axis. I have given you the values. Now can you calculate what is the value of a? I mean, what is the value of NC, normalization constant? It's quite simple. How can I do that? Simple. I am considering it is all space. Now guys, initially I told you what is all space. Now I have given you the space. Space is only one dimensional space. Then the range I have given to you, 0 to 2. So in the integration I will be putting 0 to 2, definitely. Then what is the value? What is the normalized equation, normalized function? It is ax square. You cannot put x square because it is not normalized. So ax square is normalized function, so I am putting ax square. Again ax square. And I told you that your function is your function is present, or your wave function is only valid on the x-axis or along the x-axis. That means I will be putting only dx over here. And as it is normalized, so it will become what? 1. Now from here you need to solve the integration only. So a is a constant, so I am taking this out from the integration. 0 to 2 x to the power 4 tx equals to 1. So if you solve this, you will be getting a square, then x to the power 5 divided by 5, 0 to 2 1. Then if you put these values once again, you will be getting 32 by 5 minus 0 equals to 1. And from here if you calculate a, you will be getting a equals to root over of 5 divided by 32. That means this normalization constant a has value root over of 5 divided by 32. That's all. So in this way you can find your normalization constant one by one. Okay, so is that clear? What is normalization constant, or how can you get your normalization constant? If a function is not normalized and I give you all these informations, can you calculate the normalization constant? Just write y or n, yes or no, in the comment box. Now I am getting another important question. What is the unit for a? There is no such units for a. There is no such unit for a. Do you know why? Because this function, this wave function, this x square, do you have any unit for the x square? No. So why would you expect you will be getting the unit for a? There is no such unit for a. Is that clear? How to get your normalization constant? So if a function is accepted, it's fine, you know, easily. But if a function is not accepted, that means it is suppose not normalized. You can easily normalize it by multiplying a normalization constant and by applying this normalization theory, normalization concept. You can easily calculate the normalization constant value. And this question generally comes in IIT JAM examination. So I hope you have seen JAM 2021 question paper, and from here, from this year, I am thinking, suppose JAM level is this, I will be making you ready till that level. Why do you know? Because I don't want to take risk like even 1%. Because some questions are like too much complicated they made. Because IIT Bangalore made the question. Nobody expected that kind of question in JAM 2021. Nobody. Even cutoff will be lower. Like the lowest cutoff I hope you will be getting. Cutoff will be lower, but they gave the questions like gate level questions in the JAM examination. So you have to be ready for the situation, and that doesn't mean that whenever you are preparing for JAM you can't crack the examination. Like out of 60 questions, 35 to 40 questions, they are very easy questions. You can solve them, you can easily get into IIT. But left 25 to 20 questions, like too much, little bit complicated they are giving you. Okay, so that like in the previous year questions you can't find these kinds of questions as well. But yeah, why I told you the question paper was easy? Because 35 to 40 questions you can easily solve. So if you solve this question, you can easily get into IIT. So why question is tough? But you have to be ready for these questions as well. Got it? Next, move forward. Now we understood what are the different functions, what is orthogonality, what is normalization. We understood everything. Now I need to move forward and tell you another important function. That function is called Eigen Function. That function is called Eigen Function. Okay, Eigen Function. So what is Eigen Function? That you need to understand clearly. So suppose you have got a function psi. After solving the second order differential wave function, that is Schrodinger wave equation, you are getting a wave function psi value. You are getting a psi value, okay? And that psi value definitely will be what? Accepted. That psi value will be definitely accepted psi value. Yes, it is accepted psi value. The reason is what? The reason behind this is you are getting this psi from Schrodinger wave equation and it is satisfying all the conditions. If it is not satisfying all the conditions, it won't be accepted. So I am thinking your psi value that you are getting from the Schrodinger by the solving of Schrodinger wave equation, by the solution of the Schrodinger wave equation, that wave function is accepted, I am thinking. So that wave function is actually called Eigen Function, or that accepted wave function is called actually Eigen Function. Remember, again I am repeating, Suppose you are solving your Schrodinger wave equation, which is a differential equation, second order differential equation. Once you are solving that, you are getting some value, wave function value, and that wave function is accepted wave function because it is satisfying all the conditions. Okay, as it is satisfying all the conditions and as it is accepted, that wave function is called Eigen Function. Okay, it's a new kind of function. That's a theoretical explanation. And the corresponding energy value, remember, I am telling you a very important thing. Corresponding energy, corresponding energy value, this energy value is called Eigen value. Now you can ask me, what is energy value? What is energy value? Actually, I have solved this problem a lot time ago. Let me show you. Let me go back and show you. From Schrodinger wave equation, I can show you this thing. Yes, where is it? Yeah. Look at this. So if you look at this function, it was actually what? It was actually Schrodinger wave equation's second form. I told you it is another form of Schrodinger wave equation. So as it is another form of Schrodinger wave equation, definitely this psi is what? This psi is your wave function, and definitely it will be accepted because you are getting this psi from Schrodinger wave equation. So this is accepted wave function. And this accepted wave function, I told you what? This accepted wave function will be your Eigen Function. Let me write it. Eigen Function. Okay. And I told you the corresponding energy, that means the corresponding energy of the corresponding Eigen Function, or again energy of that corresponding Eigen Function, energy energy of the corresponding Eigen Function will be called what? This E will be called your Eigen value. Okay, so that is the theoretical explanation of Eigen Function and Eigen value. Theoretical explanation. What about mathematical explanation? Mathematical explanation is like that. This H cap, this is actually an operator. I told you it is total energy operator, or it is called Hermitian operator. Its value is this. Okay, its value is this. It's an operator. So this operator is operating on this function and giving you this energy value and the same function. Okay, and this energy value and the same function. So maybe it is becoming complicated for you, but within like 15 minutes it will be fully clear. So I told you the theoretical definition of Eigen Function. That means whatever accepted wave functions you are getting from Schrodinger wave equation, or after solving the Schrodinger wave equation, those accepted wave functions are called Eigen Function, and the corresponding energy values are called Eigen values. So it is your accepted wave function, and it is this wave function. From this wave function you are getting corresponding energy value. That energy value is actually your Eigen value. Okay, now I am talking, let me talk about some points regarding operator and function. Then I am coming back here and making this thing fully clear that what is mathematical definition of Eigen Function and Eigen values. Let me make this thing clear, but before I do that, I need to clear other things. What is operator, what is function? You don't know anything. You don't know anything. What is operator and what is function? So I will be starting from the beginning. Okay, so operator and function. So can you guys tell me the values of these questions, or the answer of these questions? 5 plus 2, 5 minus 2, 5 multiplied by 2, 5 divided by 2. Can you give me the answer? You can ask me why I am teaching you these things. Once again, there is a strong reason behind this. So 5 plus 2 basically gives you 7, it gives you 3, it gives you 10, it gives you 2.5. Okay, now if you look at these functions properly, those systems properly, what actually I am doing over here? What I am doing actually? Actually I am doing addition. Plus means addition. I am doing subtraction, then I am doing multiplication, then I am doing division, So what do you mean by this addition, subtraction, multiplication, division? Can anybody repeat in the tell me in the comment box? Can anybody tell me in the comment box what actually I am doing through this addition, subtraction, multiplication or division? Anybody? Because I know you know these things in your class from class 1 you know these things. But these things we will be applying in quantum mechanics as well, so that everything becomes like very basic things needs to be clear. The same thing we are applying in quantum mechanics. What do you mean by this addition, division, multiplication or subtraction? What do you mean by this? Actually, this addition means what? I can say in this way, you are doing addition, that means you are doing one operation. You are doing subtraction, another operation. You are doing multiplication, another operation. You are doing division, you are doing another operation. So all these are your operation. Not only that, let me explain you more. Suppose I am doing d by dx and x square. So actually I am doing what? Differentiation. I am doing differentiation. So differentiation is what? It is also one operation. Similarly, if I do integration of 0 to x square dx. So what I am doing over here? I am doing with this thing, I am doing integration operation. It's another kind of operation. Okay, it's another kind of operation. Similarly, if I tell you, if I do d square like this, d square by dx square x cube, what I am doing? Again I am doing double derivation, double differentiation. That is called another kind of operation. That means I am doing operation over here in mathematics. These are called mathematical operation. Not a doctor, like any doctor is doing operation. Okay, no, mathematical operation. And I am doing this mathematical operation by this positive, negative, multiplicative, division sign. So these are called, this positive sign, negative, these are called actually operator. What I am saying? These are called operator. Operator. Operator OP. Operator OP. Operator OP. Okay, operator. I am just writing OP to represent operator. Similarly, this d by dx is your operator. This integration is your operator. This double differentiation is your operator. And now you are doing operation by this operator. You know this. So okay, fine, I am doing operation by this operator. But I am doing operation on which thing? Definitely on 5 and 2. I am doing operation on 5 and 2, 5 and 2, 5 and 2, or this x square, or this x square, or this x cube. So these are basically called, in terms of mathematics, these are basically called this 5 to whatever it is, these are called function. These are basically called function. Got it? Function, fn, I am writing fn in shortcut. Fn, function. Similarly, it is your x square is your function. Function. These are basically called functions. Okay? Understood this? Operator, operation and function. So you learn two different things. One is called operator and another is called function. Now based upon these, we will be applying this concept for eigen function and eigen operator. Eigen function and I can say eigen values. But before I do that, I just want to make your operator and function thing more simpler. So what actually you do for normal function or for normal cases? For normal cases, what you do, let me show you what you are doing. You are taking your operator like dy dx and you are operating on this function, and after operating what you are getting, look at this, plus is your operator, these two are your function, and you are getting what, 7, you are getting 3, 10, 2.5. So this 7 is your what, this 7 is your new function. If you solve this thing, you will be getting 2x. If you solve this thing, I don't know what you will be getting, you will be getting some value. If you solve this thing, you will be getting like 6x, like that. Okay, so what are these things? So initially you had x square function. So once operator is operating on this function, actually you are getting a new function. What you are getting? A new function. You are getting a new function. Similarly, all these are new function, NF I am writing. So what is happening in normal cases? You have operator, you have function. So whenever this operator is operating on this function, what you are getting? You are getting new function. Okay, that is normal cases. Fine, that you can understand from these examples, whatever I have given. From all these examples you can easily understand this thing. The question arises, okay, this is for normal cases, but we need to understand what is eigenfunction, what is eigenvalues, or what is eigenfunction actually. These are normal function. What is called? It is normal function. Normal, normal function. But what about eigenfunction or eigenvalues, or what about eigenfunction? So in case of eigenfunction, so in case of eigenfunction, you have the operator, then you have the function, but whenever you will be doing this operation on this function by this operator, that means whenever you are doing operation by this operator on this function, you won't only get a new function, no. So what you would get in case of eigenfunction, you will be getting a constant and the same function. Okay, a constant and the same function. So this is what? This is actually your constant, and this is actually, look at this, these two are same function. Let me go back again, once again. Let me go back, then it will be more clear to you. Yeah. Look at this. Look at this. H was your operator. The name of the operator was Hermitian operator. And whenever I am representing one operator, I need to give one hat or cap. It is called hat or cap. Look at this. So this hat or cap is on the H. That means H is the operator. Okay. So this operator is operating on this function psi and giving you a constant. That constant is called eigenvalue, and that constant is actually your energy. And again it is giving back your same function. I mean, you had psi, you have psi. You had psi, you have psi. You are not losing your old function. You are not getting a new function. You are getting same function back. Along with that, you are getting a constant. That constant is called your eigenvalue. Understood? If you understood this thing, write you in the comment box. Now this is for what? This is for Schrodinger wave equation. So in case of Schrodinger wave equation, in case of any function or any quantum mechanical function, let me write this thing. In case of any quantum mechanical function, your eigenvalue is your energy value. Eigenvalue is your energy value. Okay, this E is nothing but energy. I told you in previous classes. Okay, so this is your eigenvalue, this is your energy value. That is for normal Schrodinger functions or for quantum mechanical functions. It is true. But if you want to understand this thing mathematically, because in JAM examination mathematical things will be coming more mathematics will be coming from this section. Okay, so let's check. So I am telling you to do this. So I am taking this function. I am giving you one function, and the function is like e to the power ax, and I am giving you the operator, and the operator is your d by dx. So can you tell me that this function is eigen function or not with respect to this operator? Can you check it? How can you check it? Simple, very simple. What you need to do? Put the operator first. And how do you represent your operator? Put a cap over here like that. Operator, put a cap. So I am putting a cap on the operator. Like this is my operator, put a cap. So d by dx is my operator, put a cap. And then I am writing my function e to the power x like this. Operator, then function. What I will be getting exactly? D by d, now make it. So this operator is nothing but your differential operator. So I am doing it. D by dx, then e to the power x. Now this differential operator is operating on this function. What I am getting? I will be getting a into e to the power x. A into e to the power ax. Okay. So now if you look at this, so actually if you look at properly, it was your old function, and in the answer also you are getting the same function back. That means you operated on this function by this operator and you got the same function back, and this a is what? A is nothing but a constant. It's a constant. So you are getting a constant and you are getting a same function, or it is called Eigen Function, or it is called Eigen Function. Why it is called Eigen Function? Reason is simple, because you are getting back your old function. So this constant is called Eigen Value. So please tell me, do you understand what I did here? Did you understand this example? What I did here? Did you understand? Please do respond. Otherwise I will be giving you next problem. Did you understand this thing? Then I will be moving to the next problem, and I will be giving a lot of problem from the simplest to the toughest. I will be giving you, and you need to tell me whether this function is Eigen function or not. Very good. Next example. Next question I am giving. So I am giving you operator, I am giving you function, and you need to tell me whether it is Eigen function or not, and if it is Eigen function, what is Eigen value, that you need to tell me. So I am giving you same operator d by dx, and I am giving you function sin 2x. Then again number 2, operator d by dx, function will be your e to the power ax square. Then again number 3, okay, let's do this. Do this thing. Do these two examples. So first of all, I am getting this one and this one. So first of all, how can I solve these problems? Number 1, I am writing this operator, this, and then function sin 2x. Actually it is meaning d by dx sin 2x. It means actually what? It means actually, if you do this thing, you know, you will be getting 2 cos x, 2 cos 2x. 2 cos 2x. That means it is not your Eigen function. Why it is not your Eigen function? You had this sin 2x function initially. You are getting cos 2x. No, it is not same function. Okay, it is not same function. That's why it is not your Eigen function. Then to look at this. So I am asking you to do that. I am asking you to do that, and I will be sure that you will be doing mistake in this case. I am quite sure that you will be doing mistake in this case. Please do that. Do that and tell me. Do that and tell me. Do that and tell me whether it is eigenfunction or not. Ashwin, you just wrote the formula of this. Okay, you just wrote the formula of sine 2x. Sine 2x equals to 2 sine x cos x. You are writing that formula. I told you to do derivation, to do this operation. Not you are just writing this formula and you are expecting that is correct. Okay. So Bikram, you are saying, okay, so first of all tell me whether it is eigenfunction or not. Yes or no? No. Mustaq, yeah, no. Kartika, yes, okay. Anybody else? Bikram, I think you are saying yes because you are giving me the function. So tell me whether it is eigenfunction or not. Because during the explanation I will be telling you that where you will be doing mistake. 2 eigen, okay. Not eigen. Okay, fine. So most of you have given me the answer that it is not eigenfunction. Why is that? If you do this integration differentiation, you will be getting what? You will be getting 2ax e to the power ax square. That means definitely you are getting back your same function. You are getting back your same function. But why it is? Why is that? Why it is not the eigenfunction? Why you are telling me? I am telling you it is eigenfunction. Okay. Why it is not eigenfunction? Anybody? Why it is not eigenfunction? Because I am getting back same function. Yeah, definitely. I am getting back same function. So yes, Aniket, yes, you are saying because of x. Okay. Very good. Come back. I told you already that in case of eigenfunction, you are operating your function and you are getting a constant and the same function. So in this case, you are getting same function. That's fine. But is this a constant? No, it's not constant. It's not a constant. Why? Because look at this. Here, x is with respect to x, you are doing differentiation. That means with the change of x, how this function is changing, that you are representing by this expression. That means x is your variable, not the constant. So in this constant term, except this function, you are having this x. So is x constant? No, x is the variable. So definitely it will not be a constant. So as it is not a constant, it is not eigenvalue, and if it is not eigenvalue, it is not eigenfunction. Okay. Very interesting problem is this. So very good. Now let me give you a bunch of other examples. So I am giving you operator, I am giving you function, and please do answer by comment, and please do write the question number. So I am giving you question number 1, question 1. So whenever you are writing the answer, please write 1, then put your answer. Okay, and tell your answer, whether it is eigenfunction or not. If it is eigenfunction, what is the eigenvalue? Just write the question number as well, okay, so that it doesn't get mixed. So the operator will be your d square by dx square operator, and your function will be your sine 2x. Second operator same, it will be your sine 3x. Number 3, same operator, it will be your 6 cos 4x. Number 4, d square by dx square 5x cube. Number 5, d square by same operator, here it is 1 by x. Okay, so I am giving you these 5 problems, and can you tell me whether the functions are eigenfunctions or not? I am giving you these examples, more examples. Again, d square by dx square is your operator, and again d square by dx square is your operator. Again I think it's enough, it's done. Or I am not giving you this operator, I am giving you this operator. And your function will be this. One, not a eigenfunction. Okay. Okay, you have given me a lot of answer. Aniket, 1, yes. Okay. Ashwin, you are saying 1, not a eigenfunction. Okay. Mushtaq, you are saying only first 3 are eigenfunctions. Okay. Aniket, second, yes, -9. Very good, Aniket. You are doing great. Mushtaq, you are doing great. So first of all, look at this. I know that you will be doing mistakes in this mathematics. Please do understand properly. It is second derivative. So number 1, d square by dx square sine 2x. You have this function. For the after the first derivative, you will be getting my cos 2x, 2 cos 2x. After second derivative, you will be getting -4 sine 2x. So you are getting back your same function. That means this -4 is your constant. So this will be your eigenvalue. This will be your eigenfunction. Definitely. Next, second one, sine 3x, same thing. So if you do the same thing, you will be getting what? That d square by dx square. I am just writing the answer. Sine 3x. It will be giving you -9 sine 3x. If you do this, that means you are getting back same function. So because of that, it is your eigenvalue. Because it's a constant, it is your eigenfunction. I will be giving you much complicated examples, nothing to worry. These are simplest examples, but some of you are doing mistakes, so I can't avoid these things. Next, 6 cos 4x. 6 cos 4x. Let's do it. d square by dx square. 6 cos 4x. It will be giving you 6, then multiplied by -16. Okay, just 1 second. 6 cos 4x. Let me do this. So first of all, you will be doing 6 is here. Okay, then 4 sine cos 4x. Okay, again I am doing another 4. I will be getting. Okay, so that means I am getting -16 6 cos 4x. -16 6 cos 4x. So it was your function, and it is, you are getting back your function. So what is your eigenvalue? Definitely your eigenvalue will be -16 will be your eigenvalue, and this will be your eigen function. That's all. No, video is not buffering. Please check your internet connection. It's fine. So you are getting this thing. So this is also your eigenfunction. Number 4, 5x cube. So d square by dx square 5x cube. So you'll be getting, or 5 is here, then d by dx, you will be getting 3x square. Okay, and then 5 into, if you are doing this into 3, then into 2x. So you are overall you are getting 3 into 5 into 2, 30x. That means you are not getting back your 5x cube. You are getting another function. That means it is not your eigenfunction. Okay, next problem, last problem from here, I think. Next problem is 1 by x. So if you do 1 by x, you will be getting what? Let's do this. I know most of you forgot the integration, basic integration differentiation. Most of you. I know this. This happens actually because we are not familiar with these mathematical terms. Okay. X to the power -1. So -1 x to the power -1 -1. So -1 x to the power -2 I am getting after first derivation. Okay. And after that, I have to do the derivation. Okay, so Just let me shift it a little bit. Okay, so this is your problem. Look at this. So after first derivation you are getting this thing. So if you are doing second derivation, I mean another derivation, you cannot come back to this function. That means this function is not your eigen function even. Okay, next example is this: d square by dx square b e to the power minus 5x. d square by dx square into b e to the power minus 5x, this function. So according to this function, so b is the constant. So if I am doing first derivation, I am getting what? I am getting minus 5 e to the power minus 5x. Yeah, if I am doing the second derivation, I am getting what? b into minus 5, again minus 5 I am getting e to the power minus 5x. That means from here I can write 25 b e to the power minus 5x. So look at this, b e to the power minus 5x was there, you are getting b e to the power minus 5x, and it is your constant. So definitely this is your eigen value and this is your eigen function. Got it? Number 6 is done. Number 7 example is the last example of this kind examples. It's d2 dx to ln 2x. Okay, its operator, and this operator is operating on this function. So guys, can you tell me this operator, what do you mean by this operator? You should know this, but I am asking you, what do you mean by this operator? What do you mean by this operator? Anybody? Yes, good evening Vignesh. What do you mean by this dx operator, dx2 operator? Anybody? Very good Aniket, very good. So this operator means actually d square by dx square. And why? Because it is dx2, it means this, and ln 2x you have. So if you do this thing, what you will be getting actually? If you do this this differentiation, I think you will be getting this 2 by 2x. 2 by 2x. So if it is 2 by 2x, is that eigen function? No, it is not eigen function, because you are not getting the previous function. Once again, it is not your eigen function. Now these kinds of simplest examples are done. Now I am going to the tougher examples, then toughest examples I will be going. So I am giving you this operator h by 2 pi I del by del x. This is your operator, and I am giving you e to the power I kx. This is your function. This is your operator. This is your function. Can you tell me whether this function is eigen function or not? Please do write in the comment box. Okay, I'm sorry Aniket. Yeah, I didn't do this because simply, okay, I did only one time derivation, and if I do the second time derivation, I will be getting what? This 2 will get cut, and d by dx I will be getting what? I will be getting 1 by x. So minus 1 x to the power minus 2, like that thing. Okay, thank you so much. Yeah, but it is not your eigen function, definitely. Now come back. Look at this, whether it is eigen function or not. Whether it is eigen function or not. So these kinds of questions you will be having in examination. You won't get these kinds of simple questions. No. In examination you will be getting these kinds of questions. It's eigen function, Mushtaq. Very good. Good job. h by 2 pi I del by del x. Del by del x e to the power I kx. So this is your constant. So this part won't do anything. Just write it as it is. If you do this, you will be getting ik, then e to the power ikx once again. That means these I and these I, they are getting cut. And what you are getting at the end of the day? you are getting hk divided by 2 pi and along with that e to the power ikx. That means you are getting back your function, and this part is your constant. Definitely hk 2 pi, everything is constant. If it is constant, it will be your eigenvalue. If it is giving you eigenvalue, that is your eigenfunction. Great. Yeah, very good. Next problem will be looking like this. I am giving you this kind of thing. This is your operator e to the power alpha n. It's your function. Sorry, e to the power alpha x. This is your function, this is your operator. So can you tell me whether this function is eigenfunction or not with respect to this operator? Can you tell me with respect to this operator whether this function is eigenfunction or not? Yes, Vignesh, you will. This year you will. Tell me. I am giving you this job. Aniket, alpha to the power n. Very good. So look at this, guys. What do you mean by this? So initially I told you already, I have shown you already that dx2 is nothing but d2 by dx2. So dxn means what? It means actually what? dn divided by dxn. It is this. And if you look at this e to the power alpha x, it is actually what? E to the power alpha x is your function. Now it is very tough to do this differentiation because I don't know the value n. But what I can do, I can make this thing comparable. Like I am taking n value equals to 2. N value equals to 2. If I take this e to the power alpha x, I am getting. So what value I will be getting? 2 times derivative. I will be getting alpha square e to the power alpha n, alpha x, alpha square e to the power alpha x, and that means I am getting back my same function, and also this is the constant. That means for d2 dx2 I am getting alpha 2. For dn dxn I will be getting what? I will be getting alpha to the power n e to the power alpha x. So this alpha to the power n will be your eigenvalue. This will be your eigenfunction. Definitely. I mean this is your eigenfunction, and with respect to this operator, it is your eigenfunction with eigenvalue alpha to the power n. Simple. Done. This is very simple. Next problem I am giving you much more complicated. Let's see. I am giving you this operator d by dt, and I am giving you this function e to the power I omega t. E to the power I omega t. So can you tell me whether it is eigenfunction or not? Please do respond as soon as possible. Whether it is eigenfunction or not. Whether this function is eigenfunction or not. Can you tell me? Can you tell me whether it is eigenfunction or not? Okay. Not an eigenfunction. Mushtaq. Moinak, it's not. Karthika, yes. Aniket, yes. Ashwin, no. Okay. So let's see. Most of the students said no. Now let's see. Let's do this thing. E to the power I omega t. So this I omega. Look at this I omega. What is this? Constant. This I is your imaginary constant. It is your constant, right? So if you do this, you will be definitely getting I omega multiplied by e to the power I omega t. Definitely you will be getting this. Okay. So that definitely it is your eigenfunction. It is logically, mathematically your eigenfunction, and it is your eigenvalue, because we are doing mathematical explanation. We are doing mathematical explanation. So from mathematical explanation, this can be your eigenvalue. But if you want to understand this thing theoretically, that would be a different. Like if you apply this concept for quantum mechanics, like for an atom, this thing will be different. Okay. So mathematically, it is your eigenvalue and it is your eigen function. Mathematically, okay. And this eigenvalue contains a imaginary term. That's all. Mathematically, you can say that. Okay. Next question. Next question is about looking like this: d square by dx square plus 2 d by dx plus 3. This is your this is your operator, and I am giving you this function e to the power alpha x. So can anybody tell me what is your eigenvalue? Or do you have any eigenvalue or not? That means whether this function is eigenfunction or not with respect to this operator. Anybody? 30 seconds. Okay, a square plus 2a plus 3. Very good. Yeah. So just do the differentiation. D square by dx square 2d by dx plus 3. This is your operator and this is your function. And from there what I am doing, I am just taking this thing here, here and here. D square by dx square e to the power alpha x plus 2 d by dx e to the power alpha x plus 3 e to the power alpha x. So if you do this, you will be getting alpha square e to the power alpha x, 2 alpha e to the power alpha x plus 3 simply e to the power alpha x. From here I can write alpha square plus 2 alpha plus 3 e to the power alpha x. So what you are getting? You are getting back your same function. Along with that, you are getting this constant term. That means this is your eigenvalue, this is your eigenfunction. Okay, that's all. Last question, or second last question I am giving you. Let's see who answers this question. Let's see. So I am giving you this operator and I am giving you this function. So can you tell me with respect to this operator whether this function is eigenfunction or not? Anybody? Okay. Yes. Eigenvalues. So what is the eigenfunction? Please give me the answer. What is the eigenvalue? Please give me the answer. Aniket, 6. Very good. Yeah. So it is very simple. Del by del y x square e to the power 6y. So I am doing differentiation with respect to y, not with respect to x. That's why these two are multiplying. That's why this x square is what? It's a constant. So I am just taking this out. Then del by del y e to the power 6y. And from here what I am doing, I am just doing this differentiation. I will be getting x square 6 into e to the power 6y. And from here I can write in this way 6 into x square e to the power 6y. Okay, and logically if I do this, this will be your eigen value, this will be your eigen function. Okay, and that's all. That's all about this eigen value and eigen function. 6 your eigen value. Next question, last question, and you need to solve this question. Okay, so I am giving you a function. Function is your cos x, cos by, cos cz. This is your function, and your operator is, I am giving operator is del square operator. So do you know what is del square operator? So del square is nothing but your Laplacian operator, Laplace. It means del square by del x square, del square by del y square, del square by del z square. So can you tell me whether this operator, this with respect to this operator, whether this function is eigen function or not? If it is, tell me eigen value. If it is not, tell me it is not the eigen function. Answer. Okay, Mushtaq, you are saying it's eigen function. Ashwin, you are saying no. Aniket, you are saying very good. Yeah. So this will also be one eigen function. Yes, it is eigen function. How is that true? Simple. So I am doing this del square by del x square plus del square by del y square plus del square by del z square. And along with that I am doing this cos x, cos by and cos cz, and these are plus. That means I have to rearrange this equation in this way: del square divided by del x square, and here cos x, cos ax, cos by, cos cz. And let me copy this thing, then plus del square by del y and del y square, and the same thing I am copying, I am pasting over there. And same thing plus del square by del z and del z square definitely, and I am pasting the same thing. I will be getting that. Once I get that, now look at this. You are doing partial differentiation with respect to x only. That means y term and z term, they will be constant. If they are constant, you can take this out from the differentiation. If you do double differentiation, you will be getting your cos ax back, and along with that you will be getting minus a square, because it is cos, so 2 times the differentiation, so minus a square into this. So overall you will be getting minus a square, then same thing. Then you will be getting minus b square similarly, and same thing. And then you will be getting minus c square, and again same thing. Okay, and in this way you will be getting, minus a square, minus b square, minus c square, and the same thing. So you are getting back your same function, and you are getting these constants ABC. That means it is your eigen function, eigen value, and it is your eigen function. Simple. So in this way you will be getting this eigen function and eigen values. Okay, so these are very important. So that's all about this eigen function and eigen values. So is that clear, everybody? Some of you are, I'm seeing one thing, I'm noticing one thing, that some of you are doing a lot of mistakes over here. But please be careful, these are just mathematics, and if you want to learn quantum mechanics without mathematics, it's impossible. basic differentiation, basic integration is necessary. In the next class, we will be telling you, or we will be solving some more numericals on like, I will be giving you some examples of the wave functions. Wave function psi, and you need to check whether that psi is acceptable or that psi is not acceptable. That will be done, that we will be doing through mathematics. Okay, that we will do through mathematics. So purely I will be following mathematical way. I already showed you through graphically that how a function can be acceptable or a function cannot be acceptable. I have already shown you. Let me show you those things. Where is this? Just 1 second. Yeah, I have already shown you a lot of things through my plot. I will be showing in the next class that how can you get that whether your wave function is acceptable or not through mathematics, not through graph, because in examination graph, like every time graph won't be given, mathematical problem will be given in most of the cases. Okay, so that's all about this live class. In the next class we'll be meeting with that thing. So till then, bye bye. And now if anybody has any question regarding your JAM examination or any other thing, you can ask me. Okay, solution is coming soon. Solution of JAM 2021, like fully detailed solution, and most of the like 99.99% corrected solution is coming soon. Okay, yeah. Some of you asked me a lot of questions on those, like how many marks you are getting, which IIT you will be expecting. Guys, listen, whenever I am taking these live classes like these classes, in between the classes I won't answer those questions except topical questions. Okay, so now once live class is over, then you can ask me any question. Fine. Okay, so that's all. If anybody has any question, you can ask me. Otherwise I am just leaving, because we have taken a class like 1.9 nearly equals to 1.5 hour class. All syllabus, okay, within 7 to 8 months. And why I'm telling you this, because this chapter would take 3 to 4 classes maximum. This chapter would take. After that we need to move forward the next chapter, and then next, and we need to understand each and everything from the depth. Okay, expected cutoff for JAM category. Okay, in this year the cutoff will be like very less, 20 maybe, 20 or 20, 19, 20 like that. Okay, Ashish, why psi has no significant value? Because psi is just a wave function. Psi is just a mathematical function, nothing else. Ashish, psi is just a mathematical function. It can be real, it can be imaginary. But psi star psi or psi square cannot be real, cannot be imaginary. Every time those are real. So how can one imaginary function has some kind of significance? Or if you think that psi is real, then also psi is just a mathematical function. What kind of mathematical function? Psi is, if I told you already that psi is what? If you consider this wave, psi is just the amplitude or intensity of that wave. Psi is just that one. That's why psi is just a mathematical function. It is not a, it doesn't have any kind of physical significance. Physical significance means physics significance, like physical or actual significance, which is applicable for atomic model or like that. Aniket, yeah, till October everything will be finished. Yeah. Okay, so that's all about this class. We'll be meeting soon in the next class. Till then, bye bye.